So a lot of times in geometry, we look at proofs and they're this crazy, challenging thing that are weird and we don't understand them. But actually, proofs are really similar to something that you kind of understand every day. It's just like driving. And when you're driving, you need to know where you're going. So a proof is essentially just like good directions.
All right, the problem that we have here is a very common problem in many textbooks. You may have even seen it on your homework. And we're going to break it down, and I'm hoping that I can show you some steps that you can take that will help you be as successful as possible.
Now, typically in our modern era, we just use our phone and we put in a map and it tells us exactly the directions that we need to go. So we're actually really used to understanding what good directions look like. If you want to write a good proof, all you need to understand is how to write good directions.
The first step I always want you to do on a proof is to figure out what the heck it's asking. Because geometry is filled with vocabulary. If you don't know what it's asking, there is zero chance you're going to be able to write a good proof. So what I want to figure out here is, what does this mean? I've got here this given statement. Remember, this is what the problem gave you. You can assume that it's true. It's talking about a complement. Now, the word complement comes from the word complementary, which means things that add up to be 90 degrees. If two angles are complementary, they add to be 90. So what I know is these two angles, 1 and 2, add to be 90 degrees. And that's really important to make sure you understand off the top. You may have seen a version of this that uses the word supplement instead of complement. The word supplement means things that add to be 180. It's supplementary. So if you've seen either type of this problem, it's essentially the same process. So I know that these two are adding up to be 90. And what I'm trying to do is prove that angle 1 and angle 3 also add up to be 90. Once you figure out what the proof is asking you to do, the next step that I always want you to do if they give you a diagram is to start marking up your diagram. Start figuring out what things are. Now, what I would say here is, I would look at this and I'd say, okay, angle 1 and angle 2, these two, I might draw something like this. Just start marking up the page. Please don't write in your textbooks, though. You can always copy the diagram on another piece of paper. But angle 1 and angle 2 are 90 degrees. I might even put like a little right angle there or something to tell me that's what I'm doing. I also know in the given statement that angle 2 is congruent to angle 3. This symbol means congruent. It's a little equal sign with a squiggly on top. That stands for equals and similar, same size and same shape. So congruent. And you know these two are also equal. And so what I can kind of imagine at this point is I can take angle 3 and just replace angle 2 with it. That's essentially all I need to do here. Because these are the same measure, the same angle measure, it would make sense that this one could also be a complement to angle 1. So really in my proof, all I need to do is show that angle 1 can replace angle 2. And again, you can draw whatever is helpful on your diagram when you're doing stuff. But for me, I love to draw stuff on diagrams. It really helps me understand what I'm doing. So let's review. Start by understanding vocab. What is the question asking you? The second thing is to mark up your diagram. Now, all we need to do essentially is draw a map. We need to figure out the proof as a directions for how we know that this angle is also a complement to angle 1, just like this one.
When you're writing good directions, every step is important. You don't want to just say, oh, you'll know it when you see it, because the person who hasn't been there won't know it when they see it because they haven't been there. So when you're driving, you need good directions. Every step is important. In a proof, you need good directions. Every step is important.
So remember, as with a map, we need good directions. We need a place to start. The place that you always start with your proof is in the givens. And that's in the previous video that I mentioned. So the first thing I'm going to write down, angle 1 is a complement of angle 2, and angle 2 is congruent to angle 3. And I'm just going to go ahead and write those up here. Now remember, when you start with your given statements, the only justification that you need to write down is the word given. So I can put given in for both of those. The next step that I want to think about, if you watched the last video on our algebraic proofs, we talked about all the properties of equality. Notice this is not an equal sign, which means since it's not an equal sign, I cannot use the properties of equality on it. However, the cool thing about congruent is it already has the equal sign in it. Congruent and equal are essentially the same thing. So what you can do is you can change any congruent symbol to an equal sign. Once it's an equal sign, you can use all those properties we mentioned before. It's always a good idea to change this if you see something that's congruent all the way to an equal sign.
The other thing I hear a lot of students say in proofs is like, why do I need to explain that? Just like in a direction, when you're giving directions when you're driving, you don't just want to say, oh yeah, you know, once you get on the freeway, it's just really obvious. No, it's not. Maybe I'll be going to, I don't know which exit to take or anything else. So it may seem obvious to you, but when you're giving directions to someone else, it might not be obvious. For the same reason in the proofs, you need to write every detailed direction out.
But what I want to write down here is that angle 2 equals angle 3. And the justification for that is the definition of congruent, right? So the definition of congruent tells me that equals and congruent are really the same thing. All right, now that we've got the starting place out of the way, I need to figure out how I can get to this proof statement. Okay, I want to know that angle 1 is a complement of angle 3. I want to know that they add to be 90. And all I need to do, because I looked at my diagram, is essentially replace angle 3 with angle 2, because they're the same. So I know where my destination is, I know where I'm starting, now I need to write those steps in between. And if I'm talking about things that add to be 90, maybe I should write down the things that add to be 90. Right now, the things that add to be 90 are 1 and 2. So I'm going to go ahead and write that down. Notice I put the M in front of each angle. The M stands for measure. Anytime you give an angle a certain number of degrees, you should put the letter M in front of it. It is not a variable, it stands for the measure. And since these are adding to be 90 degrees because they're complementary, I want to make sure that I have the letter M there. My justification for this is the definition of complement, or definition of complementary. Complementary things, I've already said that they're complementary, add to be 90. So that's just the definition of complementary, and that's all you need to write down. Okay, again, when it tells you that they're complementary, you say they add to be 90. No big deal.
So if you want to give good directions, you need to know the area, you need to know the street names. And if you want to do a good proof, you need to know all the theorems and postulates. You need to know them really well. The better you know them, the easier it is to write a proof. Just like the more you know the street names, the easier it is going to be to write directions.
We've talked about things that add to be 90. Remember, angle 2 and angle 3 are the same, and all I really need to do is put angle 3 in there for angle 2. And so I can do that since I know they're congruent, or in this case, equal. So what I'm going to do is I'm going to replace angle 2 with angle 3. I'm going to say the measure of angle 1 plus the measure of angle 2, or measure of angle 3, also equals 90 degrees. Now I can do that because these two are the same. The justification that you need, the reason, is the substitution property of equality. Again, it's in that Algebraic Proofs video. You can look at that. So I'm going to go ahead and put that in there. Substitution property of equality. All right, after writing that down, I'm basically done. I've shown they add to be 90, so all I need to do is tell you that you are at your destination. All you need to do is write down what you were supposed to prove. That's your destination, right? So I'm going to write that down right here. So now the only justification you need is the definition of complementary. Okay, right here I use substitution. I can say they're complementary because they add to be 90. I'm going to go ahead and put that in there. Remember, you should always finish your proof with QED because you have finished what you set out to prove. So you're going to go ahead and write that in there too. QED, you guys finished your proof. Now again, this looks really complicated, to beginners, because it is. There's lots of things to remember. There's all these theorems and postulates and properties that you need to remember, definitions, right? But if you start to get those in your head, you're going to start to see this process repeat again and again and again. And it's going to often come down to understanding what a complement is, what a supplement is, how to use your substitution properties, and go ahead and finish your proofs.
So when you're writing your proofs, remember that you're given directions. Know the street names. Know your theorems. Write every step out. Don't expect people to know what you're talking about. And you'll find that these get a lot easier.